Alright, now we're looking at finding x and y intercepts of an equation and using them to graph quickly. So first, what are intercepts? A y-intercept is where a graph, in our case lines, crosses or in any way touches the y-axis. The x-intercept is the same thing. It's where a graph crosses the x-axis or touches it in any way. In our case, it's always going to cross for right now, but eventually we'll see graphs that don't continue in straight lines, and it's possible it just touches the axis and then bounces off. Okay, so another way of looking at it, though, all points on the y-axis have something in common in terms of what all the ordered pairs. So imagine all of the ordered pairs you'd get for points along the y-axis. Think about what they have in common. Okay, pause and think about it a little bit if you need to. Hopefully you realize what they all have in common is that they have an x value of 0. See, like this is the point 0, 1, this is 0, 2, 0, 3, 0, 4, 0, negative 4. Okay, so all of them have an x value of 0. For x-intercepts, it's the same thing, except the y value is 0. That's going to be true for all of them. So to find x-intercepts, all you're doing, to find x and y-intercepts, all you're doing is plugging 0 in for one of the values and solving for the other. So here's an easy thing. 3x plus 4y equals 12. This one lends itself great to finding x and y-intercepts because they're going to be nice whole numbers. So let's find the y-intercept first by plugging in 0 for x. 3 times 0 plus 4y equals 12. That's just 0, so we get 4y equals 12. We get y equals 3 is our y-intercept. So we plot the point 0, 3. Same thing going the other way. We're going to get 3x plus 4 times 0 equals 12. We're going to solve, and we're going to get x equals 4. Now, if you can do those in your head, that's great. Now, am I saying it's okay to only have 2 points here? Well, I don't know. Maybe it'd be beneficial for you to figure out a third. But the one great thing about intercepts is that if you're really careful, they should be really easy to find because you're using a 0, and you're really only going to use intercepts when they're nice, pretty whole numbers anyway. So in this case, yeah, it might be okay to graph with just 2 points. But if you wanted to figure out a third just to confirm, you would be okay. Okay, try this one on your own. Try figuring out the x and y intercepts, graph them, graph the line, pause, and then come back. Okay. So my y-intercept is 2, and my x-intercept, I'm going to write that as an ordered pair, so I'm just not writing y equals 2. So my y-intercept is 0, 2, and my x-intercept is negative 5, 0. If you didn't get this as positive 2, again, what you got to remember is that we're subtracting 5y, so we want to be subtracting 10. If you made that a negative 2, you'd be subtracting negative 10, and that's not going to work out right. So plot the point 0, 2, and plot the point negative 5, 0. Connect them with a line, and make sure to put your little arrows on the end, and we're all set. Okay, so this is just kind of a shortcut way of doing certain graphs, okay? And it's really important that you know what x and y intercepts are. But it's a shortcut that's only used in really specific situations. My suggestion would be only use it when you can tell right off the bat, hey look, 2, 5, 10, wow, they're all going to be whole numbers. That would be a great situation to use it in. That's it for this one.